Welcome to Math with Mrs. Leslie. In this video, you're going to see some area formulas used, but we're going to be actually using them on figures that we would call irregular figures, figures that are made up of multiple different shapes that we have formulas for, and we'll see a couple of variations of things we could see with that. We'll also see and talk about maybe a couple of word problems that might be helpful for you as well. I'm actually going to take some problems from a review set of problems that I actually did in my class today. We will not be doing every single one of them, so you might see me skip over some. I'll be skipping over them just for the sake of time, not because they're bad problems, not because they're hard problems, not because they're, there's anything wrong with them, just mainly because of the fact that they are problems in, which we don't have enough time, and I'll kind of pick and choose some things that I think might be most helpful. So the problem you see on the screen right now has this basically L shape, and your goal is to find the area of this L shape. We do not have a formula to find the area of this shape as it is. So what we'll do is we will split this figure into figures that we do have area formulas for. And in this case, the first thing I notice is this can be broken up into rectangles. When I break this up, I can there's not one specific way I can break this up. I have options. The way I would do it is I would actually draw a line across here, splitting the top into a rectangle and then the whole bottom across into a rectangle. These little tick marks that are through the top and the side here mean that those sides are congruent. So we know that up here is 3.5 centimeters as well. Excuse me. So now, for this top left rectangle, the length times width would be the area for that rectangle. So 3.5 times 8. And in that case, you will get 28 centimeters squared. The bottom rectangle, you would do, again, length times width, and it's 14 times 3.5, which will give you 49 centimeters squared. Now, we have found those areas splitting this up into two, but we want the area of that one original shape. So what we're going to do is we're going to take that 28, we're going to take that 49, and we're going to add them. When we do that, the total area of the original figure is 77 centimeters squared. All right, let's look at another one. So now you have this figure, and in this case, the figures are basically already broken up for you. They're just put together in this case, so that you see a square, and on top of it, you see a half circle, and then a half circle to the left of it. So first thing, because it's probably the easiest piece to work with, is that square. The area for a square is just like a rectangle, but since the sides are equal, you'll see on your reference sheet, if you're using the reference sheet from class, side squared. So that tells me that it's 6 times 6, or 36 feet squared for this part right here. So then, now we have to deal with those half circles. You have a couple of things you can think of. First thing I notice here is I have two half circles that are both the same size. They both have diameters of 6. And the reason I know that is because opposite sides of this square are equal, as well as all four of them. So we know that the diameter of each of these half circles is also 6. So now, since we have the diameter of those, I can see that those are equal. So the first thing I think of is, well, I have two half circles, they're equal. If I take them, I put them together, I get one full circle with a diameter of 6. So what I'm going to do is I'm going to kind of treat them as one piece. And so when I do that, I'm going to notice that my radius is 3, because it's half of the diameter. I know that my formula is 3.14 times the radius squared. So 3.14 times 3 squared. And this will give us 28.26. And that is feet squared. That's our area label, always square units. Now, some people might be thinking, well, I take that 28.26, I cut it in half because it's a half circle. Well, yes, that's true. Each one of these half circles makes up that 28.26. So technically, each one of them is 14.13 square feet. If you want to just keep that together and use the 28.26 and just know that it takes care of both of those half circles, that's perfectly fine. And then what you can do is you can take your square, so your 28.26, which actually includes both half circles, your 36, which is your square, add them together now, including everything, is 64.26 feet squared. Now, you'll always watch for rounding directions. I tend to round in my class to the nearest tenth, so this would end up becoming 64.3 feet squared. That's going to vary depending on what your directions are, so always read your directions and make sure you follow them so you gain the most amount of credit possible. All right, let's find another one to do. Again, I'm kind of skipping around a little bit just because I want to deal with problems that may be a little bit more useful, or just to see a little bit of everything. So now let's actually look at this problem. This one's interesting. We have a rectangle, but then we have 6 individual circles. What I'm going to tell you here is each one of those 6 circles are all equal, and they all have a diameter of 5. Which, if you look at your lengths of your length and width of your rectangle, that makes sense. 3 across with a diameter of 5 gives you the 15 all the way across. 2 up and down, 5 and 5 is 10, so it actually does make sense. Now, this is a situation where we're not trying to find the area of the whole thing like we did before. In this case, we're trying to find the area of the shaded. So what we need to do is find the area of the entire figure, or the area of the rectangle. That's going to be 10 times 15, which is 150. And again, make sure you have labels. Then we need to find the area of the unshaded, because our goal is going to be to take that unshaded stuff out so that we're only left with the shaded stuff remaining. So my thought is, let's find the area of one of the circles. Then, since we have 6 of them, we can just multiply that by 6 and use that number instead of having to subtract it 6 times. So now, if the diameter of the circle is, if the diameter of the circle is 5, the radius is 2.5. It's half of that. So the radius is 2.5. That means the area of one of these is 3.14 times 2.5 squared. That number is actually going to give us 19.625. Now that is only the area of one of the circles. We have 6 of them. So what we're going to do is we're going to multiply this by 6, so we make sure we include all of this unshaded stuff together in one piece. That will give you 117.75. And that is also inches squared. Next, our goal, again, is the shaded stuff. So we take the area of the whole thing, we subtract out the area of the unshaded stuff, and which are the circles here, and we get 32.25 inches squared. If you were rounding to the nearest tenth, like in my class, it'd be 32.3 inches squared as a final answer if those were your directions and where to round. So area of the whole thing, pull out those circles. We pulled them out all together instead of subtracting out each one individually. All right, let's look at one more like this. Now this one is interesting because you have basically a picture frame. Picture a flower in here. And I am no artist, so there's my flower. Oh, look at that pretty picture. So now, we have this picture frame, and we've got this picture of a flower with the frame around it. We want to know the area of the frame only. The first thing I notice is I can find the area of the unshaded much quicker than I can find the area of the whole figure. So the unshaded piece is 9 by 8. So 9 times 8, and so in this case, 72 inches squared. Okay, now we need to find the area of the whole thing, because we need to take this out of the bigger area of the whole rectangle we have. But we're not given those measurements. We have to actually find them. So the one thing I want you to realize is, let's look at the side. I want to find that entire side. I know that part of that side is 9, because opposite that, we have this portion that's going to be 9. But we have the frame going around it, and you're told, according to the labels here, that the frame has a thickness of 0.5 inches. So we have 0.5 inches. We have 0.5 inches here included with that green, and here. 0.5, if I have 2 sets of them, 0.5 and 0.5 gives us 1 whole, same as 1/2. And so if I have 9 plus 1, that means the whole side here is 10. Keeping that in mind, if we look at the top or even the bottom, same idea. If we have the 8 across from the inside picture, and we have a 1/2 inch or 0.5 on each side of that, that gives us 1 added on to the 8, and so it's 9 inches. So now I know the larger rectangle is, I'm sorry, not 8, I almost wrote 8, but it's not. 9 times 10, so 90. So this is the area of the bigger figure, the big rectangle, and we subtract out the picture in the middle, the 72 inches squared, we're left with just the frames area, which is 18 inches squared. I'd like to do one more problem. This problem is a type of word problem that I've been working on in my class. And we've been using all of these formulas within these composite figures, but sometimes we have word problems relating to different area formulas, but they don't necessarily always look for just the area. So let me show you what I'm talking about. So let's say I have the following problem, and I'll type this out so you can see what I'm thinking here. So the problem is as follows. A trapezoid has bases of 8.9 centimeters and 7.5 centimeters, and an area of 82 square centimeters. Our goal is to find what is the height of the trapezoid. So let me just elongate this here so it doesn't take up as much of our page, and then let's go back to writing. So here's what I'm going to say here. Anytime you're working backwards through a problem, or even solving a word problem that involves area, the first thing you should always do is write some kind of an equation. So in this case, the first thing I think of is the trapezoid area formula, because I'm dealing with the area of a trapezoid. So we have 1/2 times the height times base 1 plus base 2. This gives me the area of my trapezoid. Let's plug in what we know. We know the 1/2 is still there. We don't know the height. That's our unknown. That's what we're trying to find. But we do know the bases. 8.9, 7.5. The area itself, we're told, has to be 82. So now let's work through what we have and what we can combine. The 8.9 and the 7.5 we can add together. It's actually the first step to take. We add it together, we get 16.4. So we're left with 1/2 times h times 16.4 has to equal 82. Now, before we do anything to solve for h, I can still see that there's a multiplication happening on the left-hand side of my equation. I'm multiplying 1/2 h and 16.4. Now, because multiplication is what we call the commutative property, because it's commutative, okay, we can multiply in any order. We can take the 1/2 times h and then 16.4, or we can multiply the 1/2 and the 16.4 and then multiply by h. So if we cut the 16.4 in half, we multiply that by 1/2, it's 8.2 times the height is 82. Well, now we can find h because it's being multiplied by 8.2, so to undo that, we use its opposite. Divide by 8.2, and when you do that, h equals 10 centimeters. And so you get 10 centimeters for your height in this problem. I hope this video helps. You saw a couple of different things. The idea here is, in this case, there's a working backwards, but you're still just using the formula. If you think back to the other problems we did, you are still just using the formulas. It's the application of the formulas and how you're using the formulas and what you're to do with the values you obtain after that tends to vary.